Hi all, your second video is on statistics. I'm going to do a chunk of this. I hope to do the chapter in about 2 halves, and then we'll have a look at the exam questions. So this follows on from the first video where we looked at collecting data, and now we're going to look at statistics. So what will we do with all that data we collected? I showed you the data handling cycle, so at this stage we have the data collected, and this is part of the analysis of the data. So the first thing you need to know is that there are many types of averages. These are also called measures of centre. There's 3 on your course. They are the mean, the mode and the median. They are also known as measures of central tendency. You have to know that word. Questions in your exam could ask you for a measure of central tendency. The first one is the mean. It is a more fancier word for average. So the mean of a set of values is defined as the sum of all the values divided by the number of values. So in other words, add them all up, add up all of the numbers and divide it by the number of numbers. Okay, in maths language, mean is often called mu. It's a Greek letter, and then sigma, that kind of E letter, it's also Greek. It means the sum of. So add up all the numbers, and n is normally the letter used for the number of numbers. So that piece here is maths language for sum of the values over number of the values. Okay. The mode then is your second measure of central tendency. It is the value that occurs most often. So there's no calculation for the mode. You look at all of the values and you see, is there one that occurs most often? Sometimes data has no mode. Okay, but this is probably the easiest one to see, the mode. And then the median is your third measure. When you have arranged the orders in the numbers in numerical order, the median is the value in the middle. Okay, now we'll do examples where there's an odd number of numbers and an even number of numbers, because if there's an even number of numbers, then the median will be, it'll be the average of the 2 middle numbers. Okay, so the easiest way to see these is with an example. So example 1. The age of the 7 dwarves are as follows. Happy is 685, Doc 702, Sleepy 498, Sneezy 539, Dopey 402, Grumpy 685, Bashful 619. The first question says find the mean age. So what that means is add up all of those 7 numbers and divide by 7. So the sum of the values over the number of values. So 685 plus 702 plus 498 plus 539 plus 402 plus 685 plus 619, all divided by 7. So the average age, or the mean, is 590. Okay, find the modal age, or find the mode. Well, is there a value that occurs most often? Well, we look across and we see that both Happy and Grumpy is age 685, so the mode is simply 685. The median then is the value in the middle. Okay, so to do this you have to write these in numerical order. So you can see 402 is the smallest, so you can go down or up. I tend to go up, so I'm going to read here from right to left. 402, then Sleepy is 498, Sneezy is 539, Bashful is 619. We then have Grumpy and Happy both at 685, and notice that you write it down twice, it occurs twice, and Doc is 702. And then look for the value in the middle, so 1, 2, 3 down, and then from this side 1, 2, 3. So because there's 7, there's a single value in the middle, so the median is 619. Okay, find the mean, the mode and the median of 4, 0, 2, 6, 8, 2, 6 and 6. So add up all the numbers. So you see you still count 0 as a number. Okay, so 4 plus 0 plus 2 plus 6 plus 8 plus 2 plus 6 plus 6, all divided by 8. So 0 counts for a number 1, 2, 3, 4, 5, 6, 7, 8. If you think about it, this could be the scores you got in a game. So therefore a score of 0 is a score, it counts as a game. So you divide them all up and you get 4.25. So yes, it can be a decimal point because it is a statistical average of all of those values. The mode then next, well, this mode is easy. In this one it's 6, it's the value that occurs most often. And then the median. So again, we have to write these in ascending order. So 0, 2, 2, 4, 6, 6, 6 and 8. Now if you look at these lists, you can see that because these are even, okay, so I have 1, 2, 3, 4 numbers there, and I have 1, 2, 3, 4 numbers there. So can you see I have two values in the middle? I have 4 and I have 6. So write these out on a piece of paper if you need to see it yourself. So the median then is the average of them two. So 4 and 6 divided by 2 is 10 over 2. So the median is 5. So not even a number in the list. Okay, so the median is 5. So what it's telling you here is the mean and the median need not necessarily be members of the original set of values, while the mode, if it exists, is always a member of the original set of values. So in other words, the mode is always a number that was in your data set, whereas the mean and the median isn't. Okay, so when would you use which one? Why is there 3? Well, mean is, it's the average. It uses all of the data and it's easy enough to calculate. You just add them up and you divide by the number of numbers. Why we don't use the mean is when we have very extreme results. So in other words, if you were getting the average of a test in a class and you had somebody that was super good and always got 100%, and everybody else was average and they got about 50%, then the mean is a bad measure of centre to use for that data set, because the 100% person is going to pull up the mean to maybe in the high 60s. Okay, so when you have an extreme result, mean is a bad one to use. The median would be better, which is when you order them, the value in the middle. Okay, because it kind of gives you where the centre of the data lies around. Mean is not always a given data value, so that may be a disadvantage, but the big one is the extreme results. The mode, its advantage, really easy to find, and it's not influenced by extreme values. So the extreme values is always going to be a single one, it's going to be an outlier, so it's never going to be the value that occurs most often. The mode then not very useful for further analysis, and it may not even exist. The median then useful for further exam, it's unaffected by the extremes. So in other words, let me come back up to these values. So if we have a really big value or a really small value, it doesn't really matter when we're talking about the median, because the median takes the value in the middle. So it never really looks at the edge values and never takes them into account when you're calculating the median. So in that case, the median is much better measure of centre when we've got extremes. And it's easy to calculate when the data is ordered. Its disadvantage is not always a given data value. That can or may not be a disadvantage, and it can be difficult to calculate. Okay, let's try an example. The temperature in degrees Celsius was measured at noon each day for 10 days. The values, let me just take them down here so I can do the calculation. 22, 19, 27, 16, 21, 22, 18, 31, 23 and 20. Okay, so this is question 14 that I'm looking at here in front of us. The temperature in degrees Celsius was measured at noon each day for 10 days. 22, 19, 27, 16, 21, 22, 18, 31, 23 and 20. Find the mean, the median and the mode temperature. And then it says which average best describes the temperature and why. So I want you to pause the video now. I want you to answer that question and then I'll do it for you. values: 22, 19, 27, 16, 21, 22, 18, 31, 23, and 20. Okay, the mean is the average. So add them all up. And divide by the number of numbers. So I got 219 divided by 10, so 21.9 is what I'm getting from my mean. My mode, is there a value that occurs most often? Then my median, put the numbers into numerical order. So I have 16, 18, 19, 20, 21, 22, 22, 23, 27, and 31. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5 values. 1, 2, 3, 4, 5 values. So I don't have a single value, I have these two. So it's 21 plus 22 over 2, so it's 21.5. Okay, then the question says, which is the best one to use to represent the data? Well, I would say that the mean, mode, and median are very similar. Therefore, any would do. However, mode equal to 22 is a data set value, so perhaps this one. Okay, so I hope that's okay. That's how you do the mean, that's how you do the mode, that's how you do the median. Okay, if you need to practice, I would like you to do 13, and then if you would like some odd questions, I would like you to do 10 and 11. So WhatsApp me the answers, let me know how you get on. So just write page 90 and the answers, and you can do them into the groups if you wish, or send them to me privately, whichever you want. But 10, 11 and 13. Okay, let's go on to frequency distribution table then. So if the values in a distribution are arranged in ascending or descending order, showing their corresponding frequencies, the distribution is called a frequency distribution table. It's called a frequency distribution, and if the values are given in a table, it's then called a frequency distribution table. So sometimes you get a question such as this example. A casino owner tested a new 6-sided die by throwing it 36 times and recording the results. So the number is 1 to 6. Show these results on a frequency distribution table. Okay, so what you do is you write down the dice values 1 to 6, because that's all the only values a dice can take, and then you have a tally. Okay, so maybe I'll show you how I would do the tally. Let me just share this with you. Okay, So I'm just going to stop sharing now for a minute while I write down some of these values. Okay, so let me share back with you now again. So I've just written down the first row of values. Okay, so the number on the die. Okay, the values it could have. Okay, let me create some boxes. So 1, 2, 3, 4, 5, and 6. Okay, so I drew mine too big. Okay, and then I would have a tally. Then I need these ones a bit longer. Okay, and then this is the frequency. So when it says tally up here, okay, so when I see the number 4, I put a 1 in here. The number 3 here, I put a 1 in here. Number 2, I have another one. Number 6 here, and you can cross them off as you go along. 3 gives me another one here. 1 goes here. 2 goes here. 5 goes here. 6 gives me another one. 1, 1, 3. So it stops you having to count up how many 1s and 3s and 6s are in it. Now I'm just going to pretend that I had another 3 3s there so I can show you how I do my tally. So you just work line by line, number by number, and fill in the tallies. Okay, pretend I had 3 3s here. So there's my, now that's third, there's my fourth one, there's my fifth one. So what we do is we tend to put a line through it for the fifth one. There's my sixth, so I start another group of 5. So I know in my 6 now I have a frequency of, or in my 3 column I have 6 of them. I have 2 of them in 2, I have 3 of them in 1, 1, 1 and 2. And when you fill out the tally table or the frequency distribution table properly, your frequency will be different. I just took one row and made up 3 3s. Okay, so that's how you do the tally part of a frequency distribution table. Okay, so you can see here there's a group of 5 and then 2 is 7, 7 again, a group of 5 and 1 and so on and so forth. So that is showing the results on a frequency distribution table. What conclusions, if any, might the casino owner draw from the results? Well, if you throw a dice 36 times and there's 6 numbers on it, you would really expect each number to show up about 6 times. Okay, 36 divided by 6. I have 7 there, 7 there, 6 there, 7 there, 6 there. So that's fine. The number 4 doesn't occur as often as I would expect it to. It only occurs half the times. So that would make me think that this is not a fair die. In other words, it's biased in some way that 4 doesn't occur very often. And perhaps that's the nature of this casino game. Perhaps you get your money back, or you get double your money if you roll a 4. Okay, because that is the only way casinos can make money on games like this, is to somehow bias the game. Okay, so their conclusion, since the score of 4 only appears 3 times, it might be concluded that the die is not fair. Hence, the new 6-sided die would be rejected. However, the casino owner might decide that 36 throws is not enough, and what you might do is redo the experiment for another 36 times or another 100 times, and just see, maybe you were just unlucky with the number of 4s that you threw in that group of 36. So if you take it a lot more times, maybe up to 100 times, you'll have a much more data and you'll have a better feel for whether the die is actually biased or not. Okay, so that's a frequency distribution table that you must know. It comes up in your exams quite a lot, so you need to be able to do it. So how do we do the mean and the mode and the median of a frequency distribution table? Does it change? Okay, well, let's go on and let's do an example. So it's telling you you've got 3 steps. Multiply each value by a corresponding frequency, add them up, divide by the total number of frequencies. Okay, and we've some more beautiful maths language here, which we have the sum of fx this time over the sum of f. Okay, I'm not going to freak you out too much by that. Instead, what I'd like you to do is to just take down this table here, take it down, and let me show you how to do a frequency distribution table with an example, and it's far easier than having you trying to understand that maths language. Okay, so take down that table, pause the video if you have to. Okay, and then okay, so the mean, the modal mark and the median mark. Okay, let me share my page with you, and we'll work this one out. Okay, so the mean. Okay, so if you remember what a frequency distribution means, it means that I have grouped a lot of data into a table that's much easier to read. Okay, so in fact in this case what it's telling me is that I have 1 0, I have 3 1s, I have 6 2s, I have 9 3s, I have 7 4s, and I have 4 5s. Okay, now how many numbers do I have? You can add them all up, or I can add them here. So 3 and 1 4 and 6 10 19 26, so I have 30 numbers. Okay, 1 2 3 4 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30. So I divide by the number of numbers, so it's 30. Okay, and I get my answer for that. So that's what a grouped frequency table is, okay, or a frequency distribution table. It just takes a lot of data, like I've shown you here, and it groups it into a nice table up here. Okay, and you can see it's much easier to read that data in the table format than it is in this big pile of numbers that's here. Okay, but the mean is kind of cumbersome to work out when it's written like that. So is there a better way? Well, yes, there is. So the better way of working out, so I wouldn't overly recommend this way, even though it's perfectly correct. It's just too easy not to write down one of the numbers, because you can see you've got 30 numbers there and it's easy to make a mistake. So the easier way of doing it, the maths are the same, is to go, I have 1 0. So I have 1 student with a mark of 0, plus I have 3 students with a mark of 1. Now you don't really need the brackets when you're putting it into your calculator, because BOMDAS will do the multiplication before they do the plus. I'm just putting the brackets here so that you can see where I'm getting the values for. I have 6 students with a mark of 2. I have 9 students with a mark of 3. I have 7 students with a mark of 4, and I have 4 students with the mark of 5. And you know, for example, that 4 by 5 is the same as 5 plus 5 plus 5 plus 5. Okay, and then what do you divide it by? Well, you divide it by 1 plus 3 plus 6 plus 9, because this is the total number of students, plus 7 plus 4. Okay, and you can put all of that into a calculator. It is much easier than putting in the numbers at the top. I'm just putting that into the calculator now, and I'm getting a mean value of 3. Okay, now something to watch out for. The easiest mistake here is not to divide by 30, but instead to divide by 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, because I have 6 boxes. Okay, now if you make that mistake, and we've all made that mistake at some time, what you end up doing is getting a mean here that is much bigger than 0 or 1 or 2 or 3 or 4 or 5. Okay, you'll get something, well, you'll get 6 times bigger, so you'll get 18. Okay, and that's wrong, because if you look at your data, you can only get a mark of 0, 1, 2, 3, 4 or 5 here. So to get 18 just isn't possible. So 3, a mean of 3, well, I've got my most students here getting a mark of 3, so 3 feels right. Okay, so that looks right. My mode, and often called a modal interval or a modal group. We call it a modal group. Okay, well, that is this one here. Can you see 9 students got a mark of 3? So my modal mark, let's call it that, is also 3. Okay, median, yes, of course you could write all 30 values out if you wish, like I've done there, or you go half of 30 is 15. So where does the 15th value lie? So I go, what's halfway? It would be the 15th value. Okay, so where does my 15th value lie? Okay, well, 1 plus 3, I'm up here at the table, is 4, plus 6 is 10, so the 15th value brings me in here. And if I come the other way, 4 and 7 is 11, and the 15th value will lie in here. So therefore you know then that the median is also 3. Okay, or you can write them out like I've done here for the mean, and you can find the value in the middle. It'll be 3 plus 3 over 2 because it's an even number, so there's going to be 2 values in the middle. So 3 and 3 is 6 over 2, so it'll give you back the 3 again. Okay, so that's how you do the mean and the mode and the median of a frequency distribution table. Okay, so let's do some practice for you. How about you do question 8 and let me know how you get on with it, okay? So when I tell you to do these questions, you can give me the answer. This one's going to be in a table, so please do take a picture of it and send it off to me if you wished for me to check the answers. Make sure that you're keeping on top of it, okay? This is a good section of paper 2, so it's important that you know it. If you're struggling with this topic, do more of the questions, okay? You can pause this video at any time you want, do more questions, send them to me to check, okay? I don't mind checking any God's amount of them, just keep practicing. Okay, so that was what we call a frequency distribution table, any of these with discrete values. Okay, we sometimes have frequency distribution tables that have intervals or ranges. Okay, so this is how we would draw a histogram, for example. We would say the frequency distribution table below shows the time per week spent watching television by 37 people. So how do I read this? Well, it tells me here 0 to 2 means 0 is included, but 2 is not. So anybody who spent 0 or 1 hours watching telly is in this category. Anybody who spent 2, 3, 4 or 5 hours watching telly is in this category. 6, 7, 8, 9, 10, 11 is here, and so on and so forth. Okay, so these are intervals. So estimate the mean time spent per week watching telly. In which class interval does the median lie? What is the modal class? And in this example, is the time per week discrete or continuous? Okay, so it would be continuous because it's any time up to 2 hours but not 2 hours. So it would include the minutes. So in other words, if you spent 1 hour and 59 minutes watching telly, you would be here. So that's what it means by continuous values. So these are called discrete values in that they go up in set amounts. You should know that from when we looked at all the different types of data in the last video. That's discrete, they're only going up in set amounts. When you have intervals like this, it's called continuous because the time in hours can take on any value from 0 time up to, but not including, 2 hours. Okay. So how do we do this? Well, again, I'm going to do it for you. I know the answer is there, but just to talk you through this solution. Actually, I'll stop mirroring for a second just while I take down the table. Okay. So time in hours, and then the number of people. Two to 6, 6 to 12, 12 to 20, and 20 to 30. Okay, and we have 5, 9, 12, 6 and 5. Okay, mean, median and mode again. Okay. Okay, so the mean. Okay, so when you've got intervals, okay, and I'm calculating my mean, okay, so remember from the last one, I'm going to go 5 by. Now, here lies the issue. What value do I take? Do I take 0? Do I take 1? Do I take 2? How do I manage an interval? Okay, well, we take what's called mid-interval values. Okay, so that is the value in the middle of the interval. Okay, so what value is in the middle of 0 to 2? Well, it's 1. So I'm going to write my mid-interval values up here. What is halfway between 2 and 6? Okay, if you can't do it in your head, you can go 6 minus 2 is 4, divided by 2 gives me 2. What's halfway between 6 and 12? 12 minus 6 is 6, divided by 2 is 3. Halfway between 12 and 20, 20 minus 12 is 8. Oh, I forgot to do one little step for you. Okay, so 0 to 2 as a mid-interval value of 1. Okay, 6 minus 2 is 4 and half that is 2. Okay, but I have to add it on here, so halfway is 4. Halfway between 6 and 12, well, there's a gap of 6 between them, so half that is 3, so added on to the 6 is 9. Halfway between 12 and 20 is 16. Halfway between 20 and 30 is 25. So these mid-interval values up here is what I use when I'm calculating my mean. Okay, and that's why in these questions they call it an estimate. It says estimate the mean. Okay, so now I have my mean being 5, which is this 5 here, times 1, plus 9 times 4 up here. I have 12 times 9. I have 6 times 16, and I have 5 times 25. And divide that by the number of numbers. Now I know it told us in the question, I think it was 37, but we'll add them up. Okay, so put that into your calculator. I got 10 to be my mean. Okay, does that feel right? Well, I have a look to see what is my biggest number of people, which is 12. So time in hours, 10 hours. Yeah, that would make sense. Okay, where does my median lie? So this is my median interval, could be called that. Okay, so I have 37 values. Okay, divided by 2, so I have 16 and a half values on either side. So 16 values, 18 values. So 9 and 5 is 14. Yeah, I'll end up in here. 6 and 5 is 11. Yes, I'll end up in here. So my median interval is 6 to 12 hours. Okay, if it asks you for the interval, it's asking you for the time in hours that it gave in the question. You could also be asked for the modal interval. And again, it's the value that occurs most often, which is the same interval, because 12 people watched that amount of hours of TV. Okay, so the mean was 10. So the median lies in the 6 to 12 class interval, and 12, so 6 to 12 hours is the mode as well. Okay, so a hard enough question. Make sure you know how to do mid-interval values. It comes up quite a bit. Okay, and perhaps do perhaps do 10 in this question. Okay, I'm going to leave it at that. I want you to practice those 3 tomorrow, and I'm going to do then a video tomorrow on what's called measures of variability. Okay, thank you.